Hi everyone, my name is Nurin Aisyah Nakia binti Badr Hisham and my student ID is 2024217386.
Hello everyone, my name is Nurani Alia binti Muhammad Syahil and my student ID is 2024210378.
Hi guys, my name is Dania Batrisha binti Muhammad Yusuf and my student's ID is 2024206234. That's all from me.
Assalamualaikum, my name is Ahmad Danish bin Hamekwan and my student ID is 2024400138.
So, what exactly is differentiation in calculus? Well, in simple terms, differentiation is the process of finding the derivative of a function. But what does that mean? In mathematics speaking, the derivative of a function tells us how the function changes. In other words, it gives us the rate of change or slope of the curve at any point.
So, in this slide, I will explain about the technique of differentiations. There are 5 techniques of differentiation, which is number 1 is derivative of constant, linear and power function. The number 2 is sum rule. Number 3 is difference rule. Number 4 is product rule. And number 5 is quotient rule. In these 2 slides, you will find the formula for the techniques.
Let's move on and see how to solve problems in differentiation, shall we? Question 2. Find dy dx for the following function: a. 3x squared secant x plus 2 and b. y equals to 4x plus 2 divided with cos x.
Okay, so right now I will explain questions number 2a, which is 3x power of 2 sec x plus 2. So for these equations, there are 2 different functions in one equation, right? So we will use product rule. So step 1, we will differentiate the u first. So u equals to 3x power of 2. So the u prime will be 6x. And for v, we differentiate the sec first. So for v prime, it will be sec in bracket x plus 2 tan x plus 2. And we differentiate in the bracket x plus 2. So which is, it will become 1. So the v prime will become sec in the bracket x plus 2 tan in the bracket x plus 2. Okay, so the formula for product rule is dy over dx equals to uv prime and v prime u. So we already calculate the u prime, v and v prime, right? So we just substitute it into the formula. So it will be 3x power of 2 in a bracket sec x plus 2 tan x plus 2 plus 6x sec x plus 2. So for the final answer, it will be 3x power of 2 sec in a bracket x plus 2 tan in a bracket x plus 2 plus 6x sec in a bracket x plus 2. So that would be the final answer for this question.
Right now, let's move on to question number 2b. Question number 2b asks us to find the dy dx for the following function: y equals to 4x plus 2 divided with cos x. So the first thing that we need to do, we need to identify what techniques of differentiation that we can use in order to find the dy dx value. So based on the functions given, y equals to 4x plus 2 divided with cos x, we can identify that we can use the quotient rule to find the dy dx. So the formula of quotient rule is dy dx equals to vu prime minus uv prime divided with v squared. How to get the value of u prime, v, and v prime? To get the value of u, we can take it from the numerator side, which is 4x plus 2. And to get the value of u prime, you need to differentiate the value of u, which is 4x plus 2. When we differentiate the value of 4x plus 2, we will get 4. The value of v, you can take it from the denominator side, which is cos x. To find the value of v prime, you need to differentiate the value of v, which is we need to differentiate cos x. When we differentiate the value of cos x, we will get negative sin x. Already get all the value, then we can substitute the value into the quotient rule formula, which is dy dx equals to vu prime minus uv prime divided with v squared. So we will get dy dx equals to cos x multiplied with 4 minus with 4x plus 2 multiplied with negative sin x divided with cos x squared. Then we need to simplify it and distribute it. Then we will get dy dx equals to 4 cos x minus 4x plus 2 multiplied with sin x divided with cos square x. And the final answer would be dy dx equals to 4 cos x minus 4x sin x plus 2 sin x divided with cos square x. That's how we solve it. For question 3, given y ln 3x minus e power of 2x plus 1 minus tan 4y equals to 0, find dy dx using implicit differentiation.
Now, I will give an explanation on how to answer question number 3. Given the question is y ln 3x minus e by the power of 2x plus 1 minus tan 4y is equal to 0, and we have to find the dy dx using implicit differentiation. So for the first step, we will need to differentiate both sides with respect to x, which we have to differentiate each term using the chain rule or the product rule when necessary. So for the first term, which is y ln 3x, which we have to times the d over dx, we have to use product rule because there is two functions available. So y times by d over dx times ln 3x plus ln 3x times dy over dx. When we differentiate ln 3x, it will produce 1 over x and becomes y times 1 over x plus ln 3x times dy dx. Now we have to differentiate the second term, which is negative e by the power of 2x plus 1. We have to move the 2x plus 1 to the front and differentiate it. So we get the answer negative e 2x plus 1 times d, we have to differentiate 2x plus 1, and we have the answer negative e negative 2e times by the power of 2x plus 1. Now for the third term, we have to differentiate negative tan 4y. When we differentiate tan, we produce secant squared. So we produce the answer negative secant squared 4y times 4 dy dx. We have to use both the second and third term using chain rule. Now we'll put all the derivatives together. We'll put all the derivatives together, forming y over x plus ln 3x times dy dx minus 2e by the power of 2x plus 1 minus 4 secant squared 4y times dy dx equals to 0. Now we'll use in terms dy dx on the left side and the non-dy dx on the right side, and we'll produce equation. We produce ln 3x dy dx minus 4 secant squared 4y dy dx equals to negative y over x plus 2e by the power of 2x plus 1. So we have to factor out dy dx, move all the equation to the other side and finally solving the equation and producing the answer dy dx minus equals to negative y over x plus 2e by the power of 2ex plus 2e by the power of 2x plus 1 over ln 3x minus 4 secant squared.
Hello everyone, let's go with me to solve the equation 4. The equation is use the linear approximation to estimate the value of 4 root of 90.99 minus 2 over square root of 90.99. Correct to 3 decimal places. Now we move to solve the equation. For step 1, we need to recall back the linear approximation formula. For the second step, let fx equals to 4 root 90.99 minus 2 over 90.99. Now we move to the third step, where in this step we need to calculate the x minus x0. X is the given value and x0 is the initial value. As we know that x0 is the initial value, I choose 81 because it's near to the 80.99. Now we need to compute the value in the formula, where f square root of 81 equals to 4 root of 81 minus 2 over square root of 91. Next, we just calculate using the calculator, where 4 root of 81 is 3 and 2 over square root of 81 is 2 over 9. And then 3 minus 2 over 9 is 2.78. For step 5, we use the formula f prime x equals to 1 over 2x power of negative 1 over 2 minus 1 over 4x power of negative 3 over 4. Next, we just compute the value of x0, where is 81. So 1 over 2, 81, power of negative 1 over 2, minus 1 over 4, 81, power of negative 3 over 4. Next, we just calculate using the calculator and we get 5 over 108. In the last step, we use the linear approximation formula, where we just compute the value that we calculate in the step 3, step 4, and step 5. For f81, we get 2.78, f prime 81, we get 5 over 108, and negative 0.01, we get at step 3, where x minus x0. So x is 80.99 and x0 is 81. So we get negative 0.01. Next, we just calculate using the calculator, where 2.78 plus 5 over 108 multiplied by negative 0.01. So the final answer is 2.779. This is the conclusion of this assessment. This assessment tests understanding and application of core differentiation concept, including first, conceptual understanding of differentiation and its technique. Second, application of differentiation rules, product, quotient, and trigonometric rules. Third, implicit differentiation for function not explicitly solved for y. Lastly, linear approximation for estimating function value using calculus tools. The assessment emphasizes both theoretical understanding and practical computation skills in calculus.
That's all from us. Thanks for watching.